Welcome back. This is 6.3, Polygons, Perimeter, and Tessellations. So objectives are name certain polygons according to the number of sides, recognize the characteristics of certain quadrilaterals, solve problems involving a polygon's perimeter, find the sum of the measure of a polygon's angles, and understand tessellations and their angle requirements. So a polygon is any closed shape in a plane formed by three or more line segments that intersect only at their endpoints. A regular polygon is a polygon whose sides are all the same length and angles are all the same measure. Perimeter of a polygon is the sum of the lengths of the polygon's sides. So like adding all the sides together. So here's some examples. So triangle, quadrilateral or square, pentagon, hexagon, heptagon, and octagon. So types of quadrilaterals. So we have a parallelogram, a rhombus, rectangle, square, and trapezoid. And you can read their characteristics if you would like to. All right, so example 1, it says application of perimeter. So it says fencing costs $5.25 per foot. Find the cost to enclose the field with fencing. So find the perimeter of the rectangle in yards. So let's do that. So we have 28 and 42. So we're going to plug that into our perimeter equation. So perimeter equals 2 times 42 plus 2 times 28. So if you put that in your calculator, or if you do it by hand, so 2 times 42 plus 2 times 48, or 28, you get 140 yards. So now we have to convert it to feet. So 140 yards to feet would be, so we would multiply it by 3. So 140 over 1, I guess if you want to cancel out your units. So the yards cancel out. So 140 times 3 is going to equal 420 feet. Now you're going to multiply that by the cost per foot. So 420 times 5.25. So you are going to get $2,205.00. So that's how much it would cost per foot to fence the whole perimeter. All right, the sum of the measure of the angles of a polygon with n sides, so is n minus 2 times 180. So that will give you the sum of the angles. So we want to find the sum of the measures of the octagon. So octagon has 8 sides. So we would do, using that n minus 2 times 180, where n equals 8. So 8 minus 2 times 180 equals 6 times 180, which is 1,080 degrees. So that's how many degrees are in the octagon. All right, so we want to find the measure of angle A. So we would do the measure of angle A is equal to 1,080 divided by 8, because that's how many angles we have, divided by the total amount of what the angles equal. So we're going to get 135 degrees. for the measure of angle A. All right, then we would find the exterior angle B here. Remember, those are supplementary. So the measure of angle B is going to be 180 minus 135, which is going to be 45 degrees. All right, tessellations or tiling. So it's a pattern consisting of the repeated use of the same geometric figures to completely cover a plane, leaving no gaps and no overlaps. The sum of the measure of the angles that come together at each vertex is always 360. Most restrictive condition in creating tessellations is that just one type of regular polygon may be used. So these are some examples of tessellations. And then we look at the requirements for tessellations. So explain why a tessellation cannot be created using only regular pentagons. So you're going to apply that n minus 2 times 180 to find the measure of each angle of the regular pentagon. So 5 minus 2 times 180 over 5, because we want to find out what each angle will equal. So 3 times 180 over 5 equals 108 degrees. So because the 360 angle requirement cannot be met, no tessellation by regular pentagons is possible. So we'll also be doing a project for tessellations, so watch for that video. But we will be doing a project on tessellations and kind of doing a fun little thing with that. Otherwise, go ahead and work on your assignment and let me know if you have any questions.